Now let us see the reaction with halogens. They all react halogens with fairly high temperature, specifically in comparison to the alkali metals. We know that the reason because of their smaller size and higher ionization enthalpies. But yes, they all react and they form halides with general formula MX2, where your X can be your fluorine, chlorine, bromine and iodine. And N can be your any one of these alkaline earth metals. Now, we can talk about specifically beryllium. Beryllium doesn't react with these elements, these halogens directly so easily. What we find is the most difficult out of these is the formation of the beryllium fluoride, which is indirectly being formed from the thermal decomposition of this compound, which is basically sort of a coordinate complex of beryllium with fluorine, and in this ammonium ion is the counter ion. Now, when this is heated, yes, what we get is we get beryllium fluoride. We also need to know beryllium oxide, beryllium chloride, sorry. It can easily be obtained from beryllium oxide. What we do in this case is that we heat it along with coal in presence of chlorine at around 600 to 800 Kelvin. What happens is we get beryllium chloride and we get carbon monoxide in this. So this is what exactly are their properties or their reactions with halogens. Of course, these halides are ionic in nature, but yes, what we find is that the beryllium and magnesium halides are having a covalent character. More covalent character in beryllium because smaller is the size of the cation, more is the polarizing power. We know that from the Fazan's rule. So that is why what we find is beryllium halides are covalent in nature. Whereas, yes, covalent character to some extent is there in the halides of magnesium. Whereas rest of the halides are ionic in nature.